So last week we talked about world models and networking, and I started out my career in the semiconductor world.
Yeah.
I
Sorry?
was selling. I started off in the semiconductor world and in my career, and I was responsible for selling primarily into the networking sector, all the networking companies worldwide, and was part of the network processing forum for a while. So really, that discussion last week started me thinking quite a bit. Sam and I were talking about networking, world models, all that stuff. And it seems to me that networking and neuro-symbolic AI, especially the knowledge graphs portion, are a really great fit. A network topology looks just like a knowledge graph. And so, this whole discussion that we had last week, it seems like one of the best domains for the merging of the two is networking. Networking and neuro-symbolic AI should naturally go together. And I just wanted to see what you guys think about that.
Yeah.
You want to go?
So, do you want me to go?
Yeah, Sam. I mean, you have a lot of knowledge in this space. It'd be interesting to see what you think.
Okay. So here's the main thing, right? Been doing network management for almost close to about 20 years, actually, and I was one of the early engineers who built the OpenViewer SRM. So and also the OpenView suite of products, actually. So I have a lot of experience in building network management software, right? So one of the things I find is large scale network management, whether it's be it telco, enterprise WAN, or cloud fabric, basically has a fundamental problem that pure ML and rule-based systems both fail to solve adequately, right? What is the problem? The network is a causal system, right? It operates under incomplete, partially observable, rapidly changing state where intent must be translated through multiple abstraction layers, right? Into some deterministic configuration. If you look at the ONF, the Open Network Foundation, basically you can see that most of the software that they produced was basically intent-based, actually. Even ODL, like
So intent-based, you mean I need to send my packet to the Zoom packet from me to you? Is that
exactly
based?
right? So you define the problem, right? You declare your intent, and then you have the intent is actually translated into a specific set of actions, right? So that is basically intent-based, network configuration.
And it's indeterminate actions. Is that what you're saying? Because I don't know exactly the path it takes for me to get to you, my packet.
Right. So you know that there is a desired state, what you want to achieve, and you get from your current state to the desired state, right? And there you only say, this is my intent to get to the state. How it happens is completely within the framework. It takes care of that. How it takes care of that is the main issue, right? Now one of the problems that we have today is at the heart of AI-driven networking, right? What has happened is a model can write a flawless BGP config, right? As you know, you can generate, right? Can also write a flawless config but that can black hole your entire production traffic. Why is that the case? Because the fluency is not the correctness. And in networks, the difference is measured in revenue per second, right? The natural language part is the easy part, right? Verifiable intent is the hard part, which is what Sajal was also saying earlier. You steer all SaaS traffic to the lowest latency path. Sounds simple, right? Because we do that all the time. But translating it into, say, OMP policies, AR rules, and cloud on-ramp behaviors that won't violate any ZBFW postures or break BFD timers, that's where the real work lives. So those are the constraints that are there, actually, right? So when we look
Sam,
at
it's been about 20 years since I've been networking. I probably understood a couple of the acronyms you use there. But, you said fluency is not something. I didn't quite understand what you meant by that. You said fluency is not determinism. Is that what you said?
Yeah, because just because something is fluent doesn't mean because you need something which is based on verifiable stuff, right? Basically what happens is the real work lies in the nitty-gritty details, actually, right? And without a proper networking model, which is based on facts, it's very difficult to really get to steady state, actually. This has been one of the holy grails of network management all along, and this has been there for 20 years, right? So in other words, if you really look at networking, it has always been a world model, right? I mean, we talked about world models.
Before there were world models, it was world models
Yeah, I
before there were
mean,
world.
it's been forever. So we never wrote it down, actually. So what senior network engineers carry is an internal simulator, right? They know what happens when a T-lock flaps, it goes up and down. When a controller reconverges, when say an SD-WAN AVC classifies flows, that tacit model is what we are trying to externalize, so machines can reason over it. So how do you do that? That's the more interesting conversation, right? So you want some way that the tacit model, how do you externalize it so that the reasoning comes into play there? And we haven't done that, and we need to take an approach. And what approach would be the best thing, right? So first thing is, the world model, if you really look at it, isn't a diagram, right? It is a set of constraints that hold under change. Like for a network, that means a topology, state, policy, behavior, all bound together, right? So now the second thing is the
And that's
ontology.
a knowledge graph, isn't it? That can be translated into a knowledge graph.
In a way, yes, but the thing is, when you look at the say the diagram on the wall, the world model is the physics behind it, right? That's what I'm trying to say. The world model is the physics, right? The ontology is the grammar of network reality. What is that? OMP, BFD, TLOC, AR, all these things. These are just acronyms. They are nouns and verbs in a formal language, right? Most LLMs treat them as tokens. Laker treats them as entities. If you want to look at our product, we'll treat them as entities with relationships, invariants, and consequences. That's very important. Why I'm bringing this point is AI Ops really disappointed everyone, because why it disappointed was because it skipped ontology. You cannot anomaly detect your way to understanding without a structured representation of what should be true. Every alert is just a vibe. World models give
I think
alert.
what you really need is the ability, even if you were to detect anomalies in all of the telemetry, across all of the telemetry,
Right.
you need the ability to correlate that anomaly with the underlying fault.
Right.
Is that it manifests itself in the service layer,
Yeah.
but it actually occurs in the transport layer, and then if you drill down, you'll really find that something happened in the physical layer.
Right.
So the ability to model your network at each of these levels of abstraction, the service layer, the transport layer, the physical layer, you can do that in a graph, and then you can reason across these layers with the information that you have on the topology, the constraints, the classes of devices you have on the network, the classes of traffic, and to reason with that. I think, yeah, so I support your argument that that's something that is eminently possible. The promise of AI ops, where the promise was not delivered on, I think it almost seems like we might be able to actually revisit that whole topic once more.
Yeah, because the thing is, symbolic and statistical stuff aren't enemies. They are kind of like roommates, right? Why I'm saying that is LLMs are extraordinary at intent capture and pattern fluency, but ontologies and graphs are extraordinary at constraint enforcement. So when you bring all this together, the interesting architecture is one where each does what it is good at. Actually, when you combine that, it becomes extremely beautiful. Actually, right? And that's the whole idea where network management is moving. I mean, and this is where our Laker platform stands out. And Laker as the verification layer gives us a lot of power, right? I mean, Laker is the thin layer that turns plausible into provable LLMs, right? Like the
But Sam, let's keep this kind of generic because we want to keep this podcast not.
Yeah. So generally, when we talk about LLM generated network, intent goes in, verified, simulated, tested, policy aware automation comes out, right? It's not a wrap around a model. it's like the seatbelt between a model and the network, right? I mean, so kind of the most underrated word in the network automation is day two. I mean, I've been through this at several places. Like, I work with big customers, telco customers. The day two is one of the biggest things, right? I mean, because, for example, a couple of things that often come to my mind. One is the scale. Then again, how do you do troubleshooting? And the third is what I really think is the alerts, the notifications that come through for even thousands of different devices and pods, and how do you really collect that telemetry data? It's been very important. So anyone can ship a config on day zero. The question that decides whether the automation lives or dies is what happens when the topology shifts at 2 a.m. and the original intent no longer holds, right? So this is where we need to be very, very careful, and that is where the whole notion of knowledge graphs and verifiability come into play, right? Test automation is the unsung hero of trust, right? I mean, you cannot move from human in the loop to human on the loop without verification substrate that runs continuously, right? It should run not only run continuously, deterministically and against a faithful model of the live network. Trust is built test by test, right? I mean, so the intent gap is the real frontier. It's the distance between what an operator, right, means, what an LLM produces, what a controller accepts, and what the data plane actually does, right? I mean, so therefore, it is the translation of the intent all the way down. And I think that the gaps, not the model, is where the reliability is won or lost. And
And
that
I
is
think,
why I speak about this so much, like because this is a new frontier, and the way we look at network automation is changing actually. So, do you have anything to add on
yes,
this?
no, I was just saying, right? We spoke about the graph modeling, the network topology, the graph modeling, you know, constraints, and even normalizing across multi-vendor products, right? The port from a Juniper network or the interface from a Cisco network, you can actually semantically normalize them and make them, related or similar entities. And then you construct a graph out of that. And then you spoke about intent. I think what's also important is reasoning, right?
Yeah,
Given the representation of the network and the SLAs, the constraints, and the traffic, the state of the traffic in the network, and then you also express your intent, right? How do you translate that intent into action?
exactly.
And that's where reasoning plays a big role.
Yep.
So, reasoning under, I think what we're speaking about here is fairly sophisticated reasoning, and that's got to be grounded in, verifiable, provable provenance of
Yep.
facts. And such reasoning will allow you to reason over constraints, will allow you to do counterfactual reasoning. Like, I mean, you keep speaking about this popular incident. Somebody applied a change in the network and all hell broke loose. So even before you apply that change, can you reason with it, right? If I applied this change in the network, what would likely happen? That's counterfactual reasoning. And then there's also temporal reasoning, right? Basically, what it means is I can make this change now, and it might impact the network beneficially. But what would happen at a different point in time when the traffic is at peak, right? Will the change that I apply now, also survive the test of time at the time when the traffic is at its peak? So these are the questions that require fairly rigorous reasoning. And you can actually do rigorous reasoning with LLMs and with representations of the network knowledge and graphs that model the not just the graph topology, network topology, but also the constraints and the state of the graph, state of the network, as of the moment you're about to make that decision.
So in this discussion, would the equipment in a network, the routers, switches, et cetera, be the nodes in the graph, and then the policies and everything would be the edges in the graph? Is that how it would work?
Exactly. I mean, I think the network, the whole of the network really is a graph in itself, right? I mean, there are routers in there, there's switches in there, there are links between them. Now, what happens is we can turn that into a complete knowledge graph with the edges really giving you precise information, right? I mean, which allows us to reason actually. And one of the main things is generally how do you describe that, right? I mean, for example, when you talk about natural language intent decomposition, how do you really ensure that knowledge which you have captured in your knowledge graph is used to really provide the value at that's there, right? I mean, the 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 reason why this is very important is because the state space is large, but it's bounded, right? The ontology is rich but stable. So the feedback signal is brutally honest. Packets either flow or they don't. So one of the main thing is network operations is one of the cleanest test beds for grounded AI, actually. If you really look at it, actually, from a personal standpoint, I really think that is one of the main things. The second thing is the future NetOps engineer is a director, not a typist, right? And we know that actually. Their craft moves from CLI muscle memory to applying intent, defining variants, curating the ontology, that the verification layer reasons over, right? Which is what Sajad was alluding to, the multiple forms of thing. The job gets more conceptual, not less skilled, right? So the end game isn't AI runs the network. It is a verified intent pipeline. Humans express what should be true. Models propose how to make it true. World models simulate the consequences. Verification layers get the gate execution. And the network becomes a continuously proven system, not a continuously prayed over one, right? I mean, which is what it is today.
Oh.
You just give it and then you. So the problem there is when something is applied, when a remediation is applied, when do you know that the actual problem, when the problem is gone, or when is that been alleviated or not? How do you know? That is the hardest part to really track, actually.
And Sam, are
Right?
there ontologies? You mentioned ontology. Are there ontologies, standard industry ontologies for networking?
Oh yeah, absolutely. Because there are many of them which are very standard actually. Like for example, if you take we have ontologies like the Yang models, right? I mean, in fact, when I was working for earlier for a load balancing company, I in fact automated the entire Yang model actually. Then we also have the TMF. We have the there are also different formats like you have a representation like Tosca, and also there are many standard all these L2 configuration, L3 configuration devices have all been in the market for such a long time that there are specific models. They could be vendor specific, but still most of them have the underlying backbone which is the same, right? I mean. So therefore, the network modeling, like for example, there are a lot of open config is one. Then you also have IBM ontologies there. So there is quite a bit of things. And I think one of the things is also the telecommunication union also defines a lot of standards in the space actually. So there is no dearth of models. The only problem is those models are extremely complex. And so that is where you need to apply to what extent and to what depth you need to go, right? I mean, because you could take a component, drill down to the nth degree, right? Is that what you want, or you want something at a higher level, right? So therefore, this leads to more concept, like even though we say AI has come and taken over concept like domain-driven design, actually, domain-driven modeling, and also a DSL specific to the a particular thing which we are trying to for the environment which you're trying to operate is very important. Custom DSLs are really required, and so therefore what it really means is we are moving towards a world where the software is not taken over by AI. It's just that we have a more sophisticated way of really reasoning today, which we must utilize to the fullest extent. And so, as I said, that NetOps engineer is a director, not a typist. So right, I mean, so basically, the end game isn't AI runs the network. That is the main thing, right? So, what is that is happening today? In today, what you really find is that the organizations that are going to win the next decade aren't the ones with the biggest models, right? They are the ones with the best world models and the discipline to verify against them. And this is going to be the difference and the winner, right? I mean, again, I don't want to be specific about anything about our product or anything like that, but I really think that knowledge graph plays a very distinct role in network management that no other data structure handles, right? What is that? A living topology model. It gives you a causal fault graph, right? The third is it provides it.
So Sam,
I want to ask you a question.
Right.
You worked in the networking industry for such a long time. And I think for a while now, the industry has been talking about intent-based networking.
Yeah.
So much so that I think the standards bodies have tried to even standardize that terminology and maybe uh, how to manage networks via intent. So what is the state of the art in the industry? I mean, what has the industry done in this space? And how is it different from what you're just describing?
So one of the things is basically when you talk about translation, um, generally one of the problems that often arises is in the network, like let's say some kind of outage occurs actually, and you need to figure out where the issue really lies, right? I mean, now one of the problems is you have basically knock centers which try to deal with this, and there are knock operators who try to go down and in the troubleshooting space, right? Now, all you have at that level is just a problem that has occurred. Now that has to be translated, troubleshooted, and then figured out what is happening there. So there is a couple of things that are happening at that level. One is um, there is domain data which has been collected. Like for example, things like when you do, on day two, you have things like things that have happened, sites past histories. You have like site tickets, things that the top 7 alerts that happen. What was the last maintenance window that has occurred actually? And then you also have things like who are the biggest KPI offenders when you look at that the KPI offender list, right? Why I bring this point is because there is no consistent schema to describe this actually today. In other words, they put all this data in a data lake, and you have to really understand all this data, right? Now, why do you need to understand this data? Because that is one of the main things. Based on site histories, you can figure out where the real specific problem is, and so you can scope the problem. Now, having scoped the problem, that is one issue. Second thing is how do you really take that thing and apply and where how do you have to really get to the remediation part of it. So you need to know how to remediate it. So there may be really trouble tickets earlier with data on what was done and things like that, but then you need to prune all that data, right? Once you do that, then a determination, a reasoning needs to happen that this could be the probable cause for it, right? So now, if you want to automate this whole thing, it's really important that that reasoning is extremely strong. Once you reason about that, and then you know, okay, this is the root cause. Now, how do you build the remediation scripts for that, actually? You need to have something which can build those remediation scripts. Now, the remediation scripts cannot be built in vacuum. They need to be passed values. So where do you get those values from? And basically, you need something which can really parse the data, provide that, build the scripts, and pack them together. And then you have to provide it to maybe there's a verification layer with some authority really signing off on that, right? But you still, or maybe it's something which occurred so many times that it doesn't need, and by default it does say it can be applied actually. But still, there is a certain amount of stuff that needs to happen, and then that particular process has to be carried forward, and then the remediation has to be applied actually. Now that means you have to call the APIs. So something must be able to really look at all the APIs and build that for you, right? All this requires different kinds of knowledge kept in different representations, pulling them together and bridging them. Now, when you apply the stuff, how do you know that that particular problem has been resolved? You need a way to reason that too, actually, right? I mean, so there is this whole thing where the whole circle, it's a closed loop automation itself, has so many distinct points. And each of these distinct points involves a reasoning layer. There is a reasoning when it comes to looking at data that is already captured, like, the past history. There is reasoning involved when you really say, okay, what is the root cause? There is reasoning involved when you have to grab the appropriate fix for it, actually. There is also reasoning involved when you really apply the fix and you want to see whether it has alleviated it, right?
Sam, I'm going to have a reason here to stop you because we're getting short on time.
Yeah.
But Sujat, is there anything else that you'd like to say?
No, I think Sam covered this in pretty good depth. So I'll let you wrap this up.
Okay. It was very interesting topic for me personally. So I think that's it. We'll talk to everyone later.
Thank you.
Thank you.
Thank you.